Section 10.3, Calculus in Polar Coordinates. This section, we are going to find the slope of the tangent line and the area of the regions bounded by the polar curves. For the slope of the tangent line, which in the form of dy by dx, from the polar equation, which in the form r equals f of the theta, and the x is defined as r multiplied by cosine theta, y as r times cosine theta, we can replace r with the function f of theta. To find dy by dx, we use the calculus of the parametric equation. As x and y, consider the parametric equations. So dy by dx is dy by d theta divided by dx by d theta, or the derivative of the y divided by the derivative of the x with respect to theta. Since x is in the form of the function f multiplied by cosine theta, we find x prime, which is dx d theta, using the product rule to get the f multiplied by negative sine theta plus the f prime multiplied by cosine theta, or we write in the better form as the f prime multiplied by cosine theta minus the f times sine of theta. For the function y, as the function f multiplied by the sine theta, y prime or dy by d theta is derived using the product rule as well. So it's going to be f multiplied by cosine theta plus the f prime multiplied by sine theta. To obtain dy by dx, so we're going to use the expression for the dy by d theta divided by the expression from the dx by d theta, as in the box here. In this problem, we are going to find the slope of the tangent line to the following polar curves at a given point and find the equation of the tangent line in polar coordinates. The first part, to find the slope of the tangent line, or to find dy by dx. And then the second part, find the equation of the line to get the point and the slope put together using the Poisson form, like y minus y1 equals m times x minus x1. Order pair is provided in the r theta form. So this case, r equals 2, the theta is pi over 3, and the r as f of theta. From the formula, dy dx is from f prime of the function of the theta multiplied by sine theta plus the f at theta multiplied by cosine theta, all divided by the f prime of the parameter theta times cosine theta, subtracted by f at theta times sine at theta. On the side, let's work on the f prime. Since f is 4 times cosine theta, so the f prime is 4 times negative sine theta, or negative 4 times sine theta. To make it less complicated, we're going to substitute, since we know the angle theta as pi over 3, so sine of pi over 3, which is sine of 60 degrees, or square root 3 over 2. The cosine of pi over 3, or the cosine of 60 degrees, is 1 over 2. Now, the function at pi over 3, which is 4 times cosine of pi over 3, that gives us 4 times 1/2, or the value 2. The f prime at pi over 3, which is negative 4 times sine of pi over 3, give us negative 2 times square root 3. From the value that we have from the side here, we're going to replace it into the formula where the theta is pi over 3. Now we get the f prime at pi over 3 as negative 2 times square root 3, and multiply by sine of the angle, which is square root 3 over 2, plus the f at pi over 3, or the value 2, multiplied by the cosine, which is 1/2. And then all divided by the the expression f prime is negative 2 times square root 3 multiplied by the cosine, which is 1 over 2, minus the f value, which is 2 multiplied by the sine, which is square root 3 over 2. And then let's clean up the numbers. 2 and 2 cancel, 2 and 2 cancel. The simplified terms for the numerator is negative 3 plus 1 divided by negative square root 3. This is square root 3 minus square root 3. And it comes out to be negative 2 divided by negative 2 square root 3, or 1 over square root 3, or you can do the rationalized denominator to get square root 3 over 3 as the m, or the slope of the tangent line. Now we get the m value. We can use m to find the equation of the tangent line for the second part. Next, we're going to find the equation of the tangent line from the Poisson form. Y minus y1 equals m times x minus x1. We know m as square root 3 over 3. How about the other pair? From r theta in the form of 2 comma pi over 3. For the definition, x equals r times cosine theta, or 2 times cosine of pi over 3. Cosine pi over 3 is 1/2, so x equals 1. For the y, which is from r times sine theta, or 2 times sine of pi over 3, we get 2 times square root 3 over 2, so we get y equals square root 3. The other pair, x1, y1, is the other pair, 1 comma square root 3. Then put them together using the Poisson form to get y minus square root 3 equals the m, which is square root 3 over 3, multiplied by x minus 1. And simplify a little bit more to get y equals square root 3 over 3 times x minus square root 3 over 3 plus square root 3, which can be simplified more as square root 3 is square root 3 over 1, multiply top and bottom by 3. And the simplified form of this equation is square root 3 over 3 times x plus 2 times square root 3 over 3.